So let's describe a more complex system where you have a spanner, but now instead of the spanner being horizontal, it's at some oblique angle. Spanner arm's down here and it's at some oblique angle which we'll call alpha from the horizontal. And furthermore, we have a force on the spanner which is not straight down and it's not perpendicular, but it's somewhere in between. And we'll say that that force is acting at angle alpha to the horizontal. So how can we work out the moments of this system? Well, we know that a moment is a force times a distance, and the distance is a perpendicular distance, so we need to work out all of those components. To work out the components of the force, we have to work out horizontal and vertical components. The best way to do it, if you can't do it, if you're just starting off, the best way to do it is to say that this force is the diagonal of a parallelogram. And that parallelogram has a horizontal force and a vertical force. And if we know that angle alpha there, we can see that this horizontal force, which is along there or along there, it's actually acting along here. We know this horizontal force is F cos theta. And we can see if that's theta there, this will be theta in here. And so that this vertical force is F sine theta. So they're the two components now of the oblique force. So we no longer need to consider that force when we're talking about the moments, but we need to consider the components. We have to work out the moment due to the horizontal component and the moment due to the vertical component. Well, the tricky part is to work out what are the moment arms for each of these components. Well, if we take this horizontal component, remember each component or each force has its own line of action. We can take, there's a horizontal along there, and you can imagine that, and it has a perpendicular distance back to the pivot point of the bolt. And so here, this distance here, we know, well, if we know this distance here and we know that angle alpha there, we know that's alpha there. So we know that this distance here is d sine of alpha, because we know that angle alpha there, we know this is alpha here. Now similarly, the vertical component has a line of action going down through here, and it has a perpendicular distance back to the pivot point. And that distance there is d cos of alpha. So that's how to find those moment arms. You remember that there's a line of action and you take the perpendicular distance back to the point P. So now, the total moments in this system, the sum of the moments will be the vertical moment plus the horizontal moment. And each of those is force times perpendicular distance. So for vertical, it's F sine theta times its perpendicular distance, which is d cos alpha. And because it's going around, we're twisting the bolt in the counterclockwise direction, and that force is in the counterclockwise direction, it's positive. For the horizontal component, its force is F cos theta, and its perpendicular distance is d sine alpha. And it's also twisting in the positive direction. So that's the sum of the moments. Sometime you might actually be given these distances here, which makes the calculation much simpler if you know that distance and that distance there. But if you don't, you can use trigonometry to work those out. But remember, you use the line of action in order to work out the moment arm. Now, there are many different types of moment systems you will come across, but that seem complex, but they are just analogous to this system where you have a spanner where you've twisted something around and the spanner is no longer at a nice horizontal angle, but it's at an oblique angle, and the force is at an oblique angle. And if you can understand how this system works and you can see those perpendiculars and their moment arms back to the bolt, then you can use this type of system in order to understand how you can work out most oblique systems and therefore work out your moment.